Hi, Srivalli.
Hi, Shanti.
Okay, what's your demo today? You are starting on this AIOPS, right? Uh,
Yeah. This is about AI
for,
ops. Yeah,
for automating the IT operations
yeah.
solutions you are presenting. Okay,
Mm,
you
yeah.
can explain that.
Okay. Um, Hi, I'm Srivalli. I have about 16 years experience in IT industry that includes various roles. My latest experience being at Microsoft Redmond, Washington. Today, I'm going to demo um, about transforming IT operations, tackling challenges through AI ops solutions. As part of my job coaching on Azure Cloud DevOps and generative AI services. Let's start with the agenda. We're going to go through the current process first. So the current process, when I say current process, it's the traditional process without implementing AI or ML ops. And then we are going to talk about what the org chart looks like for IT operations, the stages and the roles. Actually, we are going to talk about the roles in the org chart that manages IT operations, key stages and methods organizations follow for IT support and operations, summary of traditional IT ops challenges. So what are the challenges faced by traditional IT operations? So faced by the organizations which have implemented IT operations with traditional principles or traditional methodologies. Advantages of AI ops in IT support and operations. And then we're going to talk about how AI ops practice can solve the above issues. And then gonna talk about some key takeaways. To start with, what's the current process? Current process utilized by IT operations teams in organizations. Organizations typically manage IT support and IT operations through a blend of manual processes, automated tools, and service management frameworks, such as information technology infrastructure library. And just a quick look at the org chart of the roles involved in IT operations org. There's going to be a CIO, and then under CIO there's a VP, and under VP there could be something like a DevOps lead and IT operations manager. Now, this IT operations managers or takes care of the IT operations, both related to the customer support and the operations. And then under IT operations manager, there is IT support engineer, network administrator, system administrator, database administrator, help desk specialist. And then IT support engineer um, is is there to manage level 1, level 2, level 3 support. The reason why we are talking about the org here is to get a good idea or a complete picture of how many resources are involved in IT operations today with traditional implementation of IT ops. Key stages and methodologies followed for IT support and operations. There is a service desk or IT help desk. The role here is IT support analyst, and then traditional process followed by the support analyst here is manual ticket logging and assignment. First level support for basic queries. So as soon as the customer calls, the service desk picks up the call, and then he or she is going to create a manual ticket first, and then there's going to be a first level support, maybe some basic queries, take some basic information from the customer and run some basic tools or automations to fix some known issues. And most of the times these don't fix the issues. We'll talk about it later, but let's move on. For example, a user calls the help desk to report an issue and the support analyst manually logs the ticket. assigns it to the appropriate team, and provides first-level support for password resets or software installation. So these are some basic functionality. Troubleshooting is what the first-level support desk or the service desk takes care of. And the challenges here is high workload on human agents and delays in ticket routing and resolution. Some of these companies have multiple levels in the customer support: L1, L2, L3, L4. And by the time the ticket reaches the right level, it takes time. And sometimes it could take months. Incident management, the incident manager is the resource here. That's the role that takes care of the incident management. Manual incident detection and reporting. The traditional process here is manual incident detection and reporting. Incidents tracked through human intervention and monitoring. For example, an incident manager only becomes aware of a server outage when a user reports the issue. The manager manually tracks and escalates the problem to appropriate team, leading to slower resolution times. So the challenge here is delays in incident detection and response, human error and inconsistency. So the next IT operations stage is problem management. In some organizations or in some companies, there is a problem manager called out for this. And then traditional process is manual root cause analysis after repeated incidents, problem identification based on human expertise. Example, a problem manager identifies frequent system crashes, manually analyzes logs, and conducts root cause analysis. This takes time and might not prevent similar incidents from recurring if not thoroughly addressed. So challenges here are time-consuming investigation, inefficient resolution leading to repeated issues. Change management, this is taken care by a change manager. And the traditional process here is manual change approvals and risk assessments. Now there's going to be code changes, and then the traditional way is someone goes there, a developer or an L4 support engineer would go there and make some changes in the product code base, and then there is a code review. And someone goes in there and reviews the code, gives the feedback, and then once the team decides that the code fixes the issue, then the check-in process starts and the deployment process starts. This is the traditional process. And example, before deploying a new software update, the change manager must manually assess the risk, gather approval from various stakeholders, and schedule the change at a convenient time, leading to potential delays in implementation. Challenges here are increased risk of human error in change implementation. So even though the code change or the configuration change is approved by the team, there's still a scope of human error and long approval process. Configuration management is taken care by configuration manager. The traditional process here is manual asset tracking and documentation, periodic audits to ensure configuration accuracy. Example, configuration managers rely on spreadsheets to manually track all IT assets, hardware and software. This system can easily become outdated, leading to misconfigurations when changes are made without proper documentation. So the challenges here are inaccurate or outdated asset tracking, risk of misconfigurations or errors. Capacity and performance management, capacity planner or system admin. And the traditional process here is reactive capacity management based on observed demand, and manual performance monitoring and tuning. A system admin notices a sudden surge in traffic requiring more server resources. Capacity planning is typically reactive with decisions based on immediate needs rather than predictive analysis, leading to delays in scaling up resources. Challenges here are reactive rather than proactive. So why are we calling this as a reactive? Because we are waiting until something happens. Like if the capacity is not enough, there's a failure or there is a performance issue. And once there is an issue, that's when we go ahead and fix it. So that's the reactive way of, that's a reactive approach. So difficulty in predicting future capacity needs. Monitoring and alerting. IT operations team takes care of monitoring and alerting. Traditional process here is manual monitoring tools set up for infrastructure, alert fatigue due to non-prioritized alarms. So when there's monitoring set up and when there is alert configured, sometimes we do tend to configure alert for more than what's needed, and that causes non-prioritized alarms as well. So example here is the IT operations team sets up basic monitoring tools to track server health. The tools generate many non-critical alerts, making it difficult for the team to prioritize and respond to critical issues quickly. Challenges here are over-reliance or manual intervention, high volume of false alarms, and noise. Automation and orchestration. IT operations or DevOps engineer limited automation, example basic scripts, manual execution of repetitive tasks like backups and patching. Example, IT engineers create simple scripts to automate server backups, but most tasks like patching and software updates are still performed manually, resulting in inefficiencies and errors during implementation. Challenges here are high operational overhead for routine tasks and increased risks of errors in manual processes. To summarize what we have seen in the table, a summary of traditional IT ops challenges: manual workload, heavy reliance on human intervention, leading to inefficiencies and delays. Reactive approach, issues are often addressed after they occur rather than being predicted and prevented. Error-prone processes, higher likelihood of human error in areas such as change management, monitoring, and ticket resolution. Scalability issues, difficulty handling large volumes of incidents, changes, and capacity demands as the infrastructure grows. Alert fatigue, monitoring systems often generate numerous alerts, making it hard to prioritize critical issues. Now let's see what are the advantages of AI ops in IT support and operations. Proactive problem solving. So the proactive problem solving, for example, can be taken care by a service or a ML model category, that's predictive analytics and machine learning models. Functionality offered by these models or these services are they use historical incident data, system performance logs, and other relevant data sets to predict when issues are likely to occur. For example, network downtimes and server failures. So they could look at the past data or the past logs, and then they could look at the current logs and the um, current data, and they could compare and they could come to a conclusion. They could predict that there's going to be a network downtime or a server failure. And this is a huge advantage of using AI ops. This is one of the examples of proactive approaches rather than reactive approaches. Automation at scale, service or model that's used here is workflow automation and event-driven architecture. Functionality offered by these services or models are these tools automate repetitive, labor-intensive tasks like software updates, backups, or ticket triaging, reducing human intervention. Enhanced decision-making services or models used here are real-time data analytics and decision-making platforms. Functionality offered by these services and models are they aggregate large amount of data, of real-time data from multiple IT systems, process the data using AI ML models and provides actionable insights. Reduced alert fatigue, correlated event monitoring, and noise reduction. These are the services or models that are that can be used, and functionality that's provided by these models or services are they analyze large number of alerts and filter out the false positives or redundant alarms by correlating events from different sources. Scalability, cloud native infrastructure with auto scaling and resource optimization. And functionality offered here is services dynamically scale IT infrastructure based on demand, ensuring optimal performance under heavy load. Let's take a look at the previous chart where we were discussing about the IT operations and the traditional approach to IT operations. Let's discuss the same table with a little change. Here we are going to discuss the advantages of implementing those IT operations with AI ops by applying AI ops. So service desk, IT help desk. AI ops application here is automating ticket categorization, prioritization, and routing. Chatbots are a very good example for implementing AI ops here for the immediate response to common queries, and then predictive ticket assignment. Applicable AI ops service or ML model is workflow automation and chatbots. And the value added here by using AI ops is automation at scale. Incident management, and the AI ops application here is automated detection of incidents via pattern recognition, predictive analytics to detect issues before they impact users, intelligent escalation. Applicable AI ops service or ML model, predictive analytics, and machine learning models. Proactive problem solving is the value add here. Problem management, AI ops application, root cause analysis via machine learning and pattern recognition across incidents to suggest fixes, automated correlation of incidents and problems. Applicable AI ops service or ML model, machine learning for anomaly detection. And then value added here is enhanced decision making. And next IT operation stage we are discussing here is change management. And AI ops application is automated risk analysis and impact assessments of changes, predicting outcomes based on past implementations, intelligent scheduling of changes. Applicable AI ops services or ML model here is risk assessment and predictive analytics. Value added by AI ops is proactive problem solving. Configuration management, AI ops application is automated discovery of IT assets, AI-based analysis of configuration compliance, predictive management to prevent misconfigurations. And then applicable AI ops service or ML model here is resource optimization and scaling solutions. Value add is scalability. And then capacity and performance management, predictive scaling based on historical patterns, automated performance monitoring and anomaly detection, AI-driven resource optimization, and applicable AI ops service or ML model is anomaly detection and event correlation. Value added here by implementing AI ops is reduced alert fatigue. Then monitoring and alerting, AI-based anomaly detection and automated alert correlation. Predictive monitoring to forecast failures. Anomaly detection and predictive analysis. These are the AI services or the ML models that can be used. Value added here is proactive problem solving, automation and orchestration, intelligent automation of repetitive tasks, AI-driven orchestration of workflows, adaptive automation based on real-time data. Intelligent automation and orchestration those are the AIOPS services or ML models that are applicable. And then value added here is automation at scale. Disaster recovery and backup, predictive analysis to identify vulnerabilities, intelligent automation of failover processes, AI-driven backup scheduling, predictive analysis, and disaster recovery automation. That's the applicable AI service or ML model. And value added here is proactive problem solving. Security and compliance, AIOps application comes into picture with automated security monitoring via AI and then AI-driven compliance checks. And then machine learning to predict security breaches, AI-driven security monitoring and compliance solutions. Those are the services applicable here. And then value added by implementing these services are enhanced decision-making. Now, the key takeaways here are efficiency gains across all stages. AIOps significantly reduces time spent on manual tasks. Incident management sees a 70% improvement in detection speed and error reduction. Automation and AI reduce human errors, and problem management experiences a 25% reduction in repeated issues. Cost savings, automation, and improved performance lead to lower operational overhead and faster processes, increasing productivity. By leveraging vast amounts of historical and real-time data, AIOps systems can detect patterns, predict potential failures, and automate repetitive tasks. These data-driven insights enable AIOps to proactively resolve incidents before they impact users, optimize resource utilization, and continuously refine IT services. So as a result, AIOps not only maintains the functionality of IT systems, but also enhances their efficiency, reliability, and scalability through intelligent automation and predictive analytics. Yeah, that's the end of the presentation. Thank you.
Okay, I'll stop recording. So you are continuing further demos, right, on these solutions, AIOPS usage?
Yeah, and there's the phase 2 where there is going to be solution planning for the implementation of a chatbot using AIOps.
Okay.